In this lesson, we're going to go over quadratic regression and application of quadratic functions. And to do that, we're going to use the most real-world situation that I could think of. Right, I'm talking about Angry Birds. And we see in the gameplay that when we shoot these birds from their slingshot, they make this parabolic path before they hit the pigs. And this parabolic path can be modeled with quadratic functions. So we're going to look at two different types of questions today. The first one, we're going to be looking at the features of this parabola and important information that we can gain from that. And then we're also going to figure out how we can use different information to make the quadratic equation if we're not given it. And so with this first problem, we're going to be looking at the attributes to think about real-world situations. So an Angry Bird is launched from its slingshot, and its height in feet after t seconds can be modeled by the equation h of t equals negative 4t squared plus 16t plus 3. And h of t is the height after t seconds. So we can find out, and we want to know how long before it takes the bird to reach its maximum height. What is that maximum height? And we're also going to figure out how tall the slingshot is. So what I'm going to do is I'm going to jump over to Desmos. And we're going to look at how we are going to do this. So first thing I'm going to do is type in the equation. But usually Desmos can't recognize the h of t and that sort of stuff. So instead of that, I'm just going to say y equals negative 4x squared. So I'm just changing this t to an x plus 16x plus 3. And I get this quadratic function here. And then back in the notes here, we see that h of t, which we just replaced as y, okay, is the height, and it's given to us after t seconds. So t is my independent variable here. It's going to be on my x-axis. So I can even type this in. My x-axis is going to be my time, and that's going to be in seconds. And then my height is going to be, my y-axis is going to be my height, and that's in feet. Okay, so now that I've got this in there, now it's going to be a little easier to answer these questions here. So first, we want to know how long does it take for the bird to reach its maximum height? Well, we can see the maximum value, or the maximum height, is going to be right here at my vertex point. And so if I want to know how long it takes, I'm going to look at the x value to find my time. My x value here is 2, so it takes 2 seconds for the bird to reach its maximum height. We also want to know what is that maximum height, and once again I'm going to stick with my vertex here. And my vertex is to 19, where 19 is my y value. And we already said that the y value was our height. So this means the maximum height was 19 feet. We also want to know how tall the slingshot is. So if we're thinking, we can't have negative time. So all of these values past my y-axis here, right, going left on my x-axis, all of these values are going to be negative. So we can just pretty much ignore all of these values to the left of 0. And so I want to know at what point do we start going to the positive side. And that's actually going to be at my y-intercept point, which I can see is right here at 0, 3. And so 0, once again, is my time. So after 0 seconds, the bird is 3 feet in the air. So if we're at 0 seconds, we haven't shot the bird yet, so that bird is still on the slingshot. So that means the slingshot has to be 3 feet tall because that's my y-intercept. In this next question, we're going to use what we call quadratic regression, or the regression tool, using Desmos. What regression does is if we give it a set of points, a list of ordered pairs, it can turn that into an equation. So even if we don't have it, we can still figure out all of our key features. So an Angry Bird is trying to hit a pig that is 8.25 yards away. The Angry Bird is launched from a slingshot that's 4 feet tall. When the bird was 3 feet away, it was 11 feet in the air. And so we want to know stuff about like its maximum height and that sort of stuff. But what I want to do first is make a table so we can get these ordered pairs out of the way. And so I've got two different things that I'm working with. So my x-axis isn't time this time. I see that I'm measuring yards away from my start, so distance this way, and then height this way. So my x value is going to be my distance, okay, and that's yards, which is also going to be my x value. And then the further away we are from the slingshot kind of depends on how high we are. So my y value is going to be my height again, and that's still in feet. This is my y. So my independent is the distance away, and then because the height depends on the distance from the slingshot. So I know that the pig is 8.25 yards away. And so I see this pig sitting here. That's 8.25. But I also see that it's sitting on the ground. And so we know that it's 8.25 yards away. So my distance is going 8.25. But my height, since it's on the ground, we can say that the height is 0. So my first ordered pair is 8.250. The second thing that I know is the slingshot is 4 feet tall. Well, the slingshot is where we're starting from. It's my starting point. So my distance when I'm at the slingshot is actually going to be 0 since I haven't moved any yet away from the slingshot. And then the height is 4 feet. So that's the height of my bird when it's in that slingshot since it's 4 feet tall. We also know that when the bird is 3 feet away, so that's my distance 3 feet away from the slingshot, it was 11 feet in the air. So now I've got these ordered pairs here. So let's jump over to Desmos and see how we're going to plug these in. When I'm in Desmos, I'm going to click this plus sign and I'm going to add this table. So now my x, I'm going to say 8.250 is my first point. And I can see that it's graphing this point here. Let's keep going. I've got 0, 4 was my next point. And 3, 11 was my last point. We can go ahead and label our axes again. So my x-axis is the distance in yards, and the y-axis was the height in feet. Okay, now that I have this, I've got these 3 points here plotted. And I want these in my standard form quadratic, which is y equals ax squared plus bx plus c. But I need to know what my a, my b, and my c values are. And that's where the regression tool comes into play. So I see that this table is being labeled x1 and y1. So if I want this equation to pull from this table, I need to make this into y1 and these into x1s. If you just type 1 next to the x, it automatically becomes a little like this. And now to tell Desmos to use regression here, instead of the equal sign, I'm going to type this squiggly line like this. And when I do this is I instantly get this graph, and I also get these a, b, and c values. So now I can come up with the equation. If we round to 2 points, it's going to be y equals negative 0.54 x squared, that's my a, plus my b is 3.94 x, and plus c, which is just 4. And now I can use this graph to find all of the key features. So this first one is saying it's reached its maximum height. So what is the maximum height? Because we're measuring in feet. I can come click on the vertex. Height is my y-axis. So I'm going to say my height is 11.24, just around to 2 decimal places. And how far away from the slingshot does it occur? Well, that's my x value. And my x value here is 3.67 yards away from the slingshot. My second question is when the bird was 2 yards away from the slingshot, it was how many feet in the air? So I want to know when it's 2 feet away from, or 2 yards away from the slingshot. So distance is my x, so I'm going to say, what is it when x equals 2? When I type in x equals 2 for my 2 yards away, I get this black line now. And I can see this black line intersects with my graph right here. So when my bird is 2 yards away, it tells me the height is 9.74. So to summarize our lesson from today, there are a lot of real-world applications of quadratics that we can find. I chose a more fun one today, but quadratics really help us model the path of balls, like when they're kicked in the air or thrown or something. They can measure profit and a lot of different things like that. As long as we understand all the key features of quadratics, then we can apply those key features to certain situations and we can figure out some important information like that. If we don't have the formula for the quadratic, we can use what's called quadratic regression with Desmos, and that'll give us the equation for us as long as we have at least 3 points. So I hope you had as much fun as I did in this video. Thank you for watching, and I'll see you in the next video.